future value and how we estimate the future value. So the future value, just to remind you, is equal to the present value times 1 plus I power n. Okay, so this is fine. Now, in the question, it will give you future value, the present value, the I and n. Okay, this is in the question. In other cases, sometimes I'm asking you to estimate the future value so sometimes I give you the future value, the present value, I give you I, and I need you to calculate n or to estimate n. So it means how long it takes to double, for instance, or to the $10,000 to be $50,000, considering that I is 8%. Yeah. So in this case, I'm asking about how long it takes. I'm asking about n. In other cases, for instance, future value is equal, again, present value 1 plus I power n. So I give you future value, I give you the present value, I give you n, but I'm asking you to estimate I. So what is I? Okay? For instance, if you deposit $10,000 today, and after 10 years, I give you the 10 years, it is equal 49,000. So what is the interest rate? In this case, I'm asking about the interest rates. Go back again. Generally, the standard formula of the future value is equal present value times 1 plus I times n. Generally, I'm asking you to calculate the future value. But sometimes, I'm asking you to calculate other things, such as the number of times, or how long it takes to the investments of $50,000 to be $100,000. Or sometimes I may ask you about the interest rate. So these are the three cases you may subject to answer one of them. Okay, so now I will talk about the third one. So to estimate the I, what is I? Prepare your calculator, please. Okay, and my calculator as well. Okay, now the key question is, what rate of interest will allow your investment to grow to a desired future value? For instance, if you have $1,000 and then it grow by 6%, it becomes $13,000 after, let's say, 10 years. So now I'm asking about the interest rate. What is the interest rate? What is the interest rate? So I give you the present value is $1,000. The future value is $13,000. And n is 10 years. Now what is the interest rate? This is what it means, finding the interest rate. We can determine the rate of interest using mathematical equation. We can use mathematical equation or the financial calculator or the Excel spreadsheet. Okay. Now, take this example here. At what rate of interest must your saving of $10,000 be compounded annually for it to grow to $22,000 in 8 years? Okay, and when you answer this question, do it in this format, please. Starting by future value. What is the future value? Then the present value, then n, then I. So the future value is $22,000, okay? The present value is $10,000. So the compounded annually is 8 years. So it is 8 years. And I, we don't know I. Because at what rate of interest? We're asking about I. So what is I? write down the formula like this. Future value is equal to the present value 1 plus I power n. So the future value is 22,000 is equal, the present value is 10,000 times 1 plus I, we don't know I, times or power 8. Now this come here, so 22,000 divided by 10,000 is equal 1 plus I power 8. Now this goes with this and this goes with this, so 2.2 is equal 1 plus I power 8. Yeah. We put this 2 under root. This is under root and this is under root. We will get the 8th root of 2.2 is equal 1 plus I. And we can do it. Use the calculator this. Just 2.2 in the root of 8, the power of 8. So 2.218 is equal, so it is equal 1.1035. 1 plus I. So in this case I, so just remove 1 from here and 1 from here. So I is equal 10.35%. Okay? So this is the full answer. Starting from the future value, do it in this way, and apply the equation 5. Future value is equal to the present value, 1 plus I power n. Then do it in this way. Okay? Try to do it in your calculator, please. You give the answer. You give the answer. 35. Okay. Okay? Take another example. Okay. Is working this? No? Okay, so go to this is the answer of this question. Now, let's go to the second example here. Check point 5.6. And this, solving for the interest rate I, let's go back to that previous example in checkpoint 5.5. Okay? And now recall that the previous always cost $20,000 in 10 years. Would you'd really like to have $20,000 to buy a new Prius? So the future value will be $20,000. In 10 years, you would really like to have $20,000 to buy a new Prius, but you only have $11,167. So this is the present value now. At what rate, we're asking about the rate, at what rate must your $11,167 be compounded annually for it to grow to $20,000 in 10 years? Okay, so we will go back to the same question. Okay, now, the future value is $20,000. The present value is $11,167.
10.
N is 10. I, we don't know I, so we want to estimate I. So the future value is equal to the present value, 1 plus I power n. The future value is $20,000, which is equal $11,167. 1 plus I, we don't know I, the power 10. So 1 plus I power 10 is equal 20,000 divided by 11,167. So 1 plus I is equal the 10th root of 20,000 divided by 11,167. So it is
Final answer.
6%.
Yes.
So it is 6%. Okay? So it means we need 6% as an interest rate that the $11,167 to become $20,000 after 10 years. So this is the answer. Okay? Go to the second. Checkpoint 5.6. At what rate, do it by yourself, this one. At what rate will $50,000 have to grow to reach $1,000 or $1 million in 30 years? Do it by yourself, please. Again, at what rate will $50,000, it is the present value, have to grow to reach $1 million in 30 years? So we are asking about the interest rate. We're asking about the interest rate. Okay? Do it. You can do it. Okay, so the answer is 10.5%. Okay. Okay, so you need another question, or it's fine? It's fine.
As you like.
It depends on the slides. So now let's go to the making interest rates comparable. Some banks, as I said before, or financial institutions, using the annual interest rate, okay, or the annual percent rate. Others, they are compounding the rates daily or monthly or semi-annually or 2 times or 2 months. So it depends on them. So for instance, if I told you that a friend of mine went to the bank and Bank A suggests 6% compounded annually, and another bank suggests 5.8, but this is compounded semi-annually. So what is how you can judge on this? 6% annually or 5.8% semi-annually. So what we should do in this case, we try to standardize the interest rates. What it means to standardize is like to unify the standards or the measures. This is annuity, this is semi-annual. So we either do it semi-annual or do this annually. What this called, when do it annually, we call this effective annual rates. So effective annual rates. So in order to do the comparable rates, we should calculate the effective annual rates. Because here we cannot judge on the 2 different measures. This is 6% annuity, and this is 5.8% semi-annual. So what we can do is to standardize this. We can do this as an annual. So if this annual, we can say if this is larger than this, so the 6% is larger than the 5.8%. So this is the case in making interest rates comparable. So we can compare between two different interest rates if we have different standards. The annual percentage rates indicate that the amount of interest paid or earned in 1 year without compounding. The annual percentage rate is also known as the nominal or stated interest rate. So any interest rate is compounded annually is called as nominal. Okay? This is the rate required by law. So this is generally applied in all of the banks. However, other banks, they, based on the customer needs, they calculate based on the daily or monthly or semi-annually, whatever. Comparing loans using effective annual rates. We cannot compare two loans based on average percent rates if they don't have the same compounding periods, as I suggested in the, with my friends. To make them comparable, we calculate their equivalent rate using annual compounding period. We do this by calculating effective annual rates. So how we can do this? The effective annual rate is equal 1 plus the annual percent rate divided by n power n minus 1. N or m, it doesn't matter. It's number of times. Or we can, so again, effective annual rate is 1 plus this annual percent rate is the quoted annual rate by the bank annual rate divided by how many times compounding time power. Be careful, the power is for all of the 1 plus, so it is the number of compounding minus 1. Okay, let's take example here. Take this example. Calculate the effective annual rate for a loan that has 5.45 quoted annual interest rate compounded monthly. So we want to calculate the effective annual rate. Now my question to you is, the effective annual rate is greater than the annual rates compounded monthly, for instance, or less than? What is the result could be? The effective annual rate is greater than or less than the compounded? Greater than, yes. So okay, so apply the equation here. Calculate the effective annual rate for a loan that has a 5.45% quoted annual interest rate compounded monthly. So what we can do then, 1 plus the effective annual, the annual interest is 5.45 divided monthly, so it is calculated 12 times. So 12 times power 12 minus 1. Oh, then you go to the calculator here. 1 plus 5.45 divided by 12, and this is power 12 minus 1. So it is 5.59. Okay? If we ask the investors, or let's say the borrowers, how much it cost you? How much the effective cost of his or her loan? is the effective cost is 5.45% or 5.59%? What is the real interest? This one or this one? This one. Are you sure this one? The second one. So this 5.59 is the real, the annual, but because it is compounded monthly, so he paid more installments. If it is compounded annually, so you end up 5.45 will equal the same 5.45. So there is no change. It's like doing. So which the customers or which the borrowers prefer, to compound it annually or to compound it monthly?
Annual.
I mean from the borrower's point of view. From the borrower's point of view. I mean from the one who take the loan. Which he or she prefer? To compound it annually or to compound it monthly? Annual. Why? Because he paid less interest. But from the bank point of view, monthly, because he received more cash flow. So this is the difference between the bank point of view and the borrower's point of view. Okay, take another example to see. Okay, so calculating the effective annual rate or effective annual rate, assume that you just receive your first credit card statement. Be careful for this example. And the average percent rate listed on the statement is 21.7%. This is the annual percentage rate. When you look closer, you notice that the interest is compounded daily. What is the effective annual rate? What do you think? The effective annual rate is greater than 21.7% or less than 21.7%? What do you think first? Before you answer the question, is greater than? Yes, it's greater than 21.7%. Okay, how you can answer this? So again, 1 plus 21.7% divided by 365 times 365 minus 1. So the answer is 24.22%, which is greater than 21.7%. So it is 24.22%. Okay? The effective, yes. But this is for this case. We ignore the implication of inflation rate and the taxation and the default rate. But this is very simple things. When we talk about investment, we have to consider the inflation rate. Okay? Okay, check yourself now. What is the effective annual rate on quoted or stated rate of 13% that is compounded monthly? So, do it. Where is your calculator? 13 point something. 0.8. If mistakenly your answer below the 13%, it means you are wrong.
Yeah.
Try to do the calculations again. Okay. Continuous compounding. Continuous compounding. This is compounding for infinity. Continuous compounding. when the time intervals between when interest is paid are infinitely small, very small, per minutes, per seconds, we can use the following mathematical formula to compute the effective annual rate. The effective annual rate is equal, the E is the exponential, which is equal 2.17, power quoted rate minus 1, where E is the number 2.71. Again, this is if it is continuously. It's very small compounded rate or compounded number of times. Okay, take this example here, example 5.10. What is the effective annual rate on your credit cards with continuous compounding if the annual percent rate is 18%? So the effective annual rate is equal E 2.17 power 18%, 0.18, minus 1. So it is now 2.17 power 0.18 minus 1. Sorry? 71. Sorry, 71. $2.71. So 2.71 power 0.18 minus 1. So it is 19.65%, around this. 19%. Okay, so this is if it is continuously compounded. Okay, now we finished the chapter 5. Just remind you the main key terms. Annual percentage rates is calculated based on the annual rates. Compounding, it's how many times we compounded a year. And discounting, what is the rate that we discount the present value or the future value. Effective annual rates, we know the effective annual rate and the equation of this. The future value is the future payments. The future value interest factors, nominal, this nominal is the same of the effective rate. The present value is the value of today. And the present value of the interest factor is the interest rate. Simple interest is no compounding for the interest rates, and the timelines, we talk about the cash flow streams. Okay, we finished chapter 5. Tomorrow, not tomorrow, on Saturday, we will talk about the chapter 6. Okay? No, there's no revision. So inshallah, on Saturday, we'll talk about chapter 6. Okay? يلا يعطيكم العافية وإن شاء الله نشوفكم في يوم السبت.